So once we finish this problem, right, you'll have everything for all 10 problems. And run this on. If you don't have it done, I know some of you already have it done, right? So you were able to figure it out. So in exercise bottom page 4, if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet after t seconds is given by the equation y equals 40t minus 16t squared. Find the velocity when t equals 2. Now Friday, right, we went back to section 2.1, pointed out that we estimated this velocity, the instantaneous velocity is equals to, back in section 2.1, right, using a table of values, right, a sequence of average velocities, okay? So now we're going to calculate the velocity exactly, right? We're not going to estimate it, we're going to calculate it exactly. So our equation for the height of the ball as a function of time is y equals 40t minus 16t squared. And so I'm going to, for function notation, I'm going to use h of t as the height as a function of time. H of t is equal to 40t minus 16t squared. And visually, what's happening is, right, here's the earth, I guess, and the ball is going straight up in the air, and it comes right back down, okay? Practically, that's what's happening. But h of t here gives us the height of the ball as a function of time, right? And this is a quadratic. And so the graph of h of t is not the flight path of the ball. It's just telling us as a function of time what the height of the ball is. And so h of 0, right, is 0. And using what we learned in pre-calculus, right, you can find the maximum height of the ball is reached at t equals 1.25 seconds, which means it hits the ground at 2.5 seconds. And so this is not the flight path of the ball. This is just telling us what the height of the ball is at each point in time, okay? This is the flight path of the ball over here. Straight up, straight down. This is just telling us how high the ball is as a function of time, okay? As time elapses. All right, so finding the velocity when t equals 2 is equivalent. So here is t equals 2, okay? Finding the velocity when t equals 2 is equivalent to the slope of the tangent line at t equals 2. So here's our parabola, or quadratic function. Here's the point on the parabola at t equals 2. And so the tangent line at t equals 2, or it just touches the graph there. And the slope of that tangent line is the velocity of the ball at t equals 2 seconds. Okay. All right. So A, right, in this case, from our definition of the derivative at A, right, A equals 2 in this case, right, 2 seconds. And so we got to calculate f prime of 2. And I'm going to use the second form of the derivative on page, top of page 2. Okay. Instead of x going to a, we've got t going to a, right? T replaces x. And so the limit as t goes to 2 of f of t minus f of 2 over t minus 2. Again, I'm using the second form of the derivative at a on top of page 2. Okay, I'm using the second form, not the first, the second. All right, I've been mixing it up in these examples. All right, so this is equal to, the limit is t approaches 2. F of t, oh man, I said f. You see the problem? Here I got h of t over here, and I got f of t over here. So let's change all the f's to an h. Get too many. I use f so much, I didn't realize that I went from h of t to f of t. So h of t, right, gives us the height of the ball as a function of time. So we're going to find h prime of 2, which is using the definition, the second form. Instead of f, we have h for the name of our function. So the limit as t approaches 2 of h of t minus h of 2 over t minus 2. Okay? Now, h of t is equal to 40t minus 16t squared. And then you know how to evaluate h of 2, right? You put 2 in for t. You have h of 2 is equal to 40 times 2 minus 16 times 2 squared. And when I did that math, I got 16. 80 minus 64 is 16. Over t minus 2. Okay. Well, now you got to do the simplification. The numerator in descending powers of t, right? We have minus 16 t squared plus 40t minus 16 over t minus 2. Descending powers of t. And now you notice that minus 16, 40, and minus 16 are all divisible by minus 8. So I can factor out a minus 8 in the numerator. And I have the limit as t approaches 2 of minus 8 times 2 t squared minus 5t plus 2. Took me a couple of stabs to get the right, factor out the right number. Okay. You can factor out a minus 8 in the numerator. And that in parentheses factors. It factors into 2t minus 1 times t minus 2. And that's all over t minus 2. Now you can see t minus 2 is a common factor in the numerator and denominator. And t never equals 2, so t minus 2's cancel. And we're left with the limit as t approaches 2 minus 8 times 2t minus 1. And now you can do the direct substitution. Put 2 in for t. We have minus 8 times 2 times 2 minus 1, which is equal to minus 24. That's the number we estimated the instantaneous velocity to be at the intersection 2.1. What are the units? Feet per second. However you want to express it. FPS for me is short for feet per second. So we estimated the velocity, instantaneous velocity, to be minus 24 feet per second at the intersection 2.1, using a sequence of average velocities. And here we're able to compute it exactly. Okay. The instantaneous velocity is equal to the slope of the tangent line, right, of our height function, h of t. Any questions on that? So that was the 10th item. For your homework. So now you can do 10 out of 10 instead of 9 out of 10. All right, got another handout for you. Looks like I'm doing about 2 out of 3 sections of handouts. 1 out of 3 are notebooks. In this section, we continue with the definition of the derivative. Brian, will you hand one more, please? All right. So put that back up. So back in section 2.7, okay, these were a definition of the derivative of f of x at x equal to some particular number, right? Some particular value of x. Okay? In this section, we allow the variable a, we allow the fixed number a to vary. And we replace the a in our definition of the derivative with the variable x. Okay? So instead of so instead of a being fixed up here, right, we now have the variable x in its place. Okay? And so f prime of x, right, is a function, is is a function of x, just like f of x is a function of x. Okay? They're not the same function, but they're both functions of x. Okay? And so f prime of x is called the derivative of the function f of x. So again, just as f of x is a function, f prime of x now is a function. Okay? So in the first exercise, we're going to find the derivative of f of x when f of x is equal to 2x minus 6. Does anybody remember what kind of a function f of x equals 2x minus 6 is? It's linear, right? The right-hand side is mx plus b form. Okay? So f prime of x gives us the slope of the function at each value of x. Okay? That's what f prime of x would be. Give us the slope of the function f of x at each value of x. Okay? So this is equal, from our definition, the limit as h goes to 0 of f of x plus h minus f of x over h. Riddle me this, ladies and gentlemen. What do you think our answer is going to be?
0.
Yeah, right? Because the graph of this is a straight line, and the slope of a straight line is the same everywhere on the line, right? And if f prime of x gives us the slope of the graph of f of x at each value of x, then this better equal 2 as well, right? All right, so let's evaluate this limit. So we have the limit as h goes to 0. F of x plus h in this case, right? Put in x plus h in for x on the right-hand side. You have 2 times x plus h minus 6. And then we got to subtract from that f of x. Be sure to put f of x in parentheses, because if you don't, you'll subtract 2x, but not minus x, minus 6. This is all over h. Well, distribute the 2 inside the parentheses. 2x plus 2h minus 6. And then we got to distribute the minus sign inside the parentheses. You have minus 2x plus 6 all over h. And now you guys simplify the numerator, right? 2x minus 2x is 0. Minus 6 plus 6 is 0. And so we're left with 2h over h. Well, h in the limit, as h goes 0, h never equals 0. So the h's cancel. We're left with the limit as h approaches 0, the number 2, which is just 2, right? The limit of a constant is just equal to the constant. So f prime of x, which is the derivative of f of x, is equal to the constant 2. Okay? So the slope of this function, slope of the graph of that function, is the same for all values of x. It's 2 for all values of x. So if you flip over your page, we're going to sketch the graph of f of x and its derivative for this problem. So just to remind myself, f of x is equal to 2x minus 6, and f prime of x is equal to 2. Okay. All right, so this is a linear function. Its x-coordinate is here at x equals 3 on the x-axis, and its x-intercept is x equals 3 here on the x-axis. Its y-intercept is y equals minus 6 here on the y-axis. And when I do this, and at home or in my office, I have a straight edge. But now I have a stapler. So when I draw that graph, you can see the straight line. Okay? So this is the graph of f of x equals 2x minus 6. Okay? Now down below, and let me make a note here. This is the graph of f of x equals 2x minus 6. Okay? It's a linear function. Down below, we're going to graph its derivative. F prime of x is equal to 2. So you know that is the equation of the graph of f prime of x equals 2, right? That's the graph of a horizontal line, y equals 2. So it crosses the y-axis at y equals 2. And then I'm just going to pick here, right? Goes through the point 5, 2. Goes through the point minus 5, 2. And so this is the graph of the derivative of f of x. It's f prime of x equal to 2. So just looking at the graph of the derivative, right, it tells us that the graph of f of x, right, the slope of f of x at every value of x is 2. Okay. And so based on this, if all you were given was this graph, you would know that f of x, this graph of f of x is a straight line, right? It's a linear function, and the slope is 2. You wouldn't know what its y-intercept is, but you would know that its slope is 2. Okay? So slope equals 2 everywhere. Okay? This is the easiest case. Okay? We're going to build up. All right. Any questions on that? So you flip your page over. We'll do something a little more challenging. we have the function g of x is equal to x squared minus 6x plus 10. And what kind of a function is this from your pre-calculus? Quadratic. This is a quadratic function. This quadratic function is the slope the same for all values of x? So changes, doesn't it? So g prime of x, from our definition, is the limit as h goes to 0 of g of x plus h minus g of x over h. Now this is where all that algebra you did, pre-calculus and other college algebra pays off, right? When you had to find the difference quotient for a function. So g of x plus h is x plus h squared minus 6 times x plus h plus 10. And then we got to subtract g of x. And be sure to put g of x in parentheses, or you'll just subtract x squared and not minus 6x plus 10 and mess up the problem. And that's divided by h. Well, x plus h squared, when you FOIL that, you get x squared plus 2hx plus h squared. And then when you distribute the minus 6 inside the parentheses, you get minus 6x minus 6h, you get plus 10. And then when you just got to distribute the minus sign, that's why you got to put g of x in parentheses. When you distribute the minus sign, you get minus x squared plus 6x minus 10. This is all over h. Cameron, are you able to see everything?
Yes, everything.
Okay. And now you got to simplify the numerator. X squared minus x squared cancels. Minus 6x plus 6x cancels. 10 minus 10 cancels. And we're left with 2hx plus h squared minus 6h over h. Now, you can either divide each of the three terms in the numerator by h, or you can factor an h out of the numerator. I decided to factor out an h in the numerator. So when you factor out an h in the numerator, you have left in parentheses 2x plus h minus 6. And now, because h never equals 0, it just approaches 0, the h in the numerator and denominator cancel, and we're left with the limit as h approaches 0 of 2x plus h minus 6. Then now you can do the direct substitution. And when you do the direct substitution, you have 2x plus 0 minus 6, which is equal to 2x minus 6. So g prime of x is equal to 2x minus 6. There's a reason why I chose that quadratic function. Because we differentiated this function, right? When we labeled it f of x is equal to 2x minus 6. We got f prime of x is equal to 2. So one of the morals of the story here that we're going to learn is that you can differentiate a derivative. Okay? We differentiate 2x minus 6, which means we can differentiate g prime of x. All right. So any questions? You should be getting good at finding derivatives by now. Okay. So if you flip your page over, we're going to graph g of x and g prime of x. And you should be getting, at this stage, get comfortable with graphing functions. So g of x is equal to x squared minus 6x plus 10. Okay. And from pre-calculus, you know how to find the vertex, right? Remember that? Find the vertex in pre-calculus, all the good stuff. Well, it turns out the vertex is at the point 3, 1. That's the bottom. And then the points 2, 2, and 4, 2 are on the graph. And then the points 1, 5, and 5, 5 are on the graph. And then you can see the y-intercept is y equals 10, which is way up here. And so that means the point 6, 10 is on the graph. And now when you play connect the dots, write a parabola. Looks something like this, right? So this 3, 4, 5, 6. So this is the graph of g of x. Okay. Now the graph of g prime of x, which is equal to 2x minus 6, looks like f of x on page 2. So the graph of g prime of x tells us the slope of g of x at each value of x. So here again is the y-intercept. Here's the x-intercept. And then draw a straight line through those 2 points. And you have the graph of g prime of x. So, looking at the graph, so at x equals 3, what's the slope of the graph of g of x? 0, right? And so that's because the tangent line at x equals 3, right? The slope of the tangent line is 0, right? So this is g prime of x equal to 2x minus 6, right? What's the slope on the graph of g of x at x equals 1? Yeah, -4, right? At x equals 1, you just put 1 in for x in g prime of x, right? 2 times 1 minus 6 is -4. So here at x equals 1, you can see the slope of the tangent line is negative, right? We're going downhill. And so the slope at x equals 1 is -4. Okay. All right. So that's what g prime of x tells us. Okay. It tells us the slope of g of x at each value of x. Okay. So it's interesting, right? A quadratic has a linear function, okay, for its derivative. Any questions on that? All right. On page 5, we calculated f prime of a back in the previous section for the square root function. Where did we do it? On page 4, in the previous section, right, we calculated f prime of a for f of x equals square root of x. So f prime of x, right, we just replace the a with x to get f prime of x. You don't have to actually go through all that, okay? So for f of x equals square root of x, f prime of x is 1 over 2 times the square root of x. And so the graph of f of x equals square root of x, right, this is another one of those functions you should be familiar with. F of 0 is equal to 0. F of 1 is equal to 1. F of 4 is equal to 2. And f of 9 is equal to 3. And so the graph of the square root function looks something like this. Okay? Well, f prime of x is equal to 1 over 2 times the square root of x. So you know when the derivative up here, right, x can't equal 0, can it? The derivative is undefined at x equals 0. Now the domain of f of x is x greater than or equal to 0. So if you want to write it this way, the domain of f prime of x is x strictly greater than 0. Okay. X can't equal 0 in the derivative. All right. So in the graph of the derivative at x equals 1, f prime of x is equal to 1/2. Okay. And then it goes up. This is an interesting graph. It goes almost straight up, right? The y-axis is a horizontal asymptote, right? F prime of x, graph f prime of x equals 0 is not a horizontal asymptote, I'm sorry, a vertical asymptote. X equals 0 is the vertical asymptote. And then you can see that the limit is x increases without bound. 1 over 2 times the square root of x goes to 0. Right? The denominator gets bigger and bigger, bigger and bigger. And 1 stays the same. So 1 divided by bigger, 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 bigger goes to 0. Okay. So the curve is something of a sharp right and flattens out above the x-axis. That's what the graph of f prime of x looks like. So this is kind of interesting that as x approaches 0 from the right, but you know you can't have x approaches 0 from the left. As x approaches 0 from the right, the tangent line is getting more and more vertical. And I have a what do I trivia for it? Yeah. Here's coordinate plane, x, y, and here is a vertical line, right? This is a vertical line. And let's say it crosses the x-axis at 5. So the equation of that vertical line is x equals 5. What's the slope of that vertical line?
Undefined.
Yeah, very good. Slope is undefined. Slope of a vertical line is undefined. So as x gets closer and closer to 0 from the right, the tangent line is getting more and more vertical. And so the derivative doesn't exist at x equals 0. Okay? Because you gotta have, when you do the derivative, it's gotta equal a number. Okay? In order for the slope to make any sense. And so the closer and closer x gets to 0 from the right, the more and more vertical the tangent line becomes. And the vertical line has an undefined slope. Okay. All right, so let's pause for here for today. We'll pick it